Hi guys, my name is Jessica Till, and the title of my presentation is Gray and White Matter Abnormalities in Adolescent Onset Schizophrenia, Comparisons between Healthy and Diseased Brains. To begin, the question being investigated within this experiment is, do the gray and white matter structures of the brain change in people diagnosed with schizophrenia? Meaning, does the structural integrity of a person's brain have anything to do with its health? The hypothesis for this question is that yes, the gray and white structures in the brain do change due to schizophrenia, as suggested in previous studies. This is not the first experiment run in an attempt to further understand schizophrenia. To continue, some predictions about the results of this experiment include 1. That a reduction of overall brain matter will be found in those with schizophrenia, and this will then lead to prediction 2, that there will be a significant difference between healthy and schizophrenic brains. Some important background knowledge about this experiment is that, like I mentioned earlier, this is not the first experiment of its kind. Other studies have suggested links between brain matter abnormalities and schizophrenia. This leads us into the objective of the experiment, which is to further solidify previous findings, while also hopefully finding new data that could point towards causes of schizophrenia in adolescents. In order to conduct this experiment, a total of 50 subjects were used, 25 with schizophrenia and 25 without. All participants were between 13 and 18 years old, and all 50 received the exact same brain scans done 3 times, each for accuracy. As a side note, all schizophrenics were actively receiving atypical antipsychotic medication. The brain scans taken showed both brain activity as well as abundance of brain matter. The brain activity was shown through colorful clusters throughout the brain. The images taken were smoothed out, and the matter was assessed using tract-based spatial statistics, or TBSS. Now on to the results for the gray matter scans. There were several areas of the brain affected, including the operculum, dorsolateral prefrontal cortex, the supplementary motor area, the primary motor cortex, the primary sensory cortex, the precuneus, anterior cingulate cortex, and the temporal lobe. All of these portions of the brain showed decreased activity in those with schizophrenia compared to the brain scans of those who were healthy. This data was significant with a p-value less than 0.001. Moving into the results for the white matter brain scans, the corpus callosum, as well as the arcuate fasciculus, were impacted structurally, and the brain fibers impacted included the pyramidal and corticopontine tract, the superior thalamic radiations, the medial lemniscus, and the left optic radiations. All of these areas showed a decrease in anisotropy. And now on to the discussion. We can say early onset schizophrenia has more severe symptoms and signs than adult onset schizophrenia. The topography of gray matter changes in adolescent onset schizophrenia, which leads to severe functional impairments in language and working memory, and specific gray matter abnormalities have indeed been linked to schizophrenia in males. And finally, I'd like to leave you with a quote directly from my article, which reads, "We have been able to characterize widespread neuropathological changes that can possibly lead to symptoms and signs of disease." With that being said, it looks like there is a very bright future for schizophrenia. Now here's my works cited, and thank you very much.